So, we left off with me showing you guys how to create an object within ES6 and then using that object as the basis for our particles. And where I last left off with it as well was I had the particle code for the object in the index page. But as I started expanding this tutorial, I realized right away that that was going to get really big fast, and so I needed to start using a proper directory structure, and I needed to start showing you guys inheritance. So let's quickly take a look at the particle.js file. So this is our original object, and all I did was move it to a separate file, and then at the bottom I am exporting it. I'm not going to bore you guys by going through that again. An alternative way of writing this is just simply by putting export up here at the top of the class. Either way will work. I prefer having this explicit export down there just because it reminds me of like React and Angular, and it's familiar. So then if we want to use that class inside our JavaScript that is on the index page, we need to define the script as a module. Without that, it won't work. You'll try to import this and we'll say you can only import a class inside a module. And so you need to set your script type to module. You can then import the particle, and everything runs exactly as it did the last time, where we're putting a bunch of particles in an array and then telling those particles to draw themselves. And if I refresh the page, you can see that's the behavior we have. So, but now I want to go one step further, right? So we want to get into more advanced particle simulations. So I need to show you guys how to extend the particle. So we have our particle here. And as you can see, it's pretty simple. We have X, Y, size, speed, and a basic gradient. I went ahead and I created another class called smoke particle. And so smoke particle is going to import particle from particle, just very similar to the way we're importing it here. And smoke particle extends particle. Now, this is where things are going to start getting pretty cool. So in ES6, and this isn't exclusive to JavaScript, but it isn't in every object-oriented programming language, so I really kind of appreciate this, is you can be very explicit about what you're inheriting from the parent class and what you're not. So if I was to import and extend particle and not run super and not run super.drawMe, literally nothing will happen because I'm not actually using anything from the parent class. Whereas if you use super, then you can run the specific functions from the parent class. And so we can see this in action. I'll also note really quickly that I added a gravity parameter to this. So what I can now do is I can come here, and instead of importing particle, I can import smoke particle from smoke particle and push a new smoke particle. And so I can go ahead and save that. And if I push that, pull, and put it in the right directory, and you can see nothing's changed. And the reason nothing's changed is all I've done is just extend it and run the previous super. Now I can show the change further by down here. We have a gravity value that is set, and we can press that into smoke particle. Then we can come to smoke particle and we can say this dot gravity equals gravity, And then down here in the draw me, again, console.log this.gravity. And what you will see when I push this, that still works, but I'm getting that gravity pass through. So you can see how I have all the same functionality from particle, but now I've extended this functionality to include the gravity. So let's take a look at this and let's see what we can keep and what we can't keep. Now, this isn't the most efficient inheritance, because in order to adjust it the way we want to adjust it, we do actually have to override a fair bit. So if we look at the constructor, we're fine keeping all of this, but we do need to define a new gradient. And because the gradient, you know what? I wonder if, either way, we could move gradient to be a property of particle. Right now, it has a limited scope within DrawMe. But even then, it would be a little hairy to try to change the color. We do want to keep this portion of it, but it's generally a wholesale swap. So I don't think we're going to actually be using the super here. So I'm going to go ahead and I'm going to comment that out. We are, however, going to use the super here, but we're going to add a couple of other properties. So we have relative density, which is the density of the particle relative to air. And I'm sure last time in the chat and whatnot, people were like, oh, you could do it more efficiently with less variables. And I ended up spending like 20 minutes agreeing with them and refactoring it, only to have to add these things again, because I'm actually going somewhere with this and I have an ADHD brain. So it's like, no, we're going to need relative density later, even though we don't need to use it for this specific effect. This might seem excessive. It's only because we're going to be using it because we're going to have more than one particle type in this particle simulation at a time. So I'm going to need that relative density between the smoke particles and the fire particles. We also want to override the Y position. Again, if you look at the original, Y is dead center. We don't want Y to be dead center. We want to be near the bottom of the screen. And then for the Y speed, again, I want to override it because I just want it to be going upwards in kind of a random way. So we don't need this console. So I went ahead and I didn't finish, but I started modifying the DrawMe function to act more like smoke. So what we have is the X speed is the X speed, same as the previous function. But what we're doing with the Y speed is we're adding the relative density and the gravity, because the gravity is going to pull against the density, and we're adding both of these things to the speed. So what this should do is it should cause the smoke to rise. And I mean, we can do this by, I can really set, or let's test this, but I could set this speed to 0, and theoretically the smoke should still rise. So let me push this, let's make sure it works, and then I'll explain kind of in detail what's happening with it, and then we'll try to extend it just a bit more. So let me go ahead and stage these changes and push them. All right, and then there we go. I mean, it doesn't look like smoke yet, and we'll get there. But you can see that we extended the class and we now have a different particle behavior. So it's gonna be a lot of code to get it to act like smoke and fire. So we're not gonna do the whole thing tonight. I'm gonna kind of make a few other adjustments and then explain the inheritance, and then we'll call it for this specific tutorial, and then we'll continue on tomorrow and actually make fire. So let's go back here, and right away I'm on a white background, so I'm gonna change this to white. So this is our gradient here, and the gradient is based off of the size of the particles, and basically I have an inner gradient that's smaller than the outer gradient. And right now our X speed is way too quick. I mean, ultimately what we want to do is we're going to want to use some form of sine equation, so that as the smoke's rising, it's kind of rising in a wave and not just spreading. But for now, we're just going to want to try to contain this a bit more. So I'm going to further override the super by setting the X speed. So this dot speed X to math dot random. And yeah, like just math.random on its own will give a number between 0 and 1. Right? I don't think we even need to put anything, and then I can say minus 0.5. So that should reduce the spread of the particles. In terms of them raising, that's fine. So what else do we want to do here? Well, what we want to do is let's do a couple of things here, right? So first off, let's add like 10 pixels to this, just so it's hovering slightly above. No, I'm wrong here. Negative. Because down is up and up is down. And then we're also going to say this dot orange y equals this dot y, which equals this dot inner height minus 10. And then what we can do is put in an if statement here that if this dot y is equal to less than or equal to 0, then this dot y equals this dot orange y. So basically what we're saying here with this piece of code, and we'll see if it works, is that when the particles hit the top of the screen, that they'll go back down to the bottom. As you can see, they're getting faster and faster as they go up, so that's good. So let's push this code and see if it works. When I actually change functionality, I put in a pop per commit, and when I just screwed up and I'm tweaking, I put in random gobbledygook. So that's what you guys are seeing there. I commit a lot when I'm coding. I think it's developed over time due to just having a lot of distractions. So saving my progress kind of became paramount. So there we go. We got our white. I screwed up here on the X because it's leaning to one side more than it should. So let's kind of fix that. So, 0.05. I'm dumb. It's times 0.5. So that'll fix that. So now, and it's looping. I don't know if you guys have noticed, it's looping. So we got it successfully looping when it hits the top of the screen, but that still doesn't look like smoke. It just looks like a line of bubbles hang up. So what we need to do is we need to oh, look at that, they're going faster and faster. I think we need to reset speed as well. That's neat. That's not speed. Yeah, and then this dot speed needs to be reset. You just do this again. Right here. So in order to get them to move up kind of one at a time, what we need to do is we need to display them one at a time. Right now, we're pushing everything, and then after everything is in, we're telling everything to draw right away. And we don't want to necessarily do that. Let me push this code. There we go. So I'm trying to think, because the way I've done this in the past is it's still getting faster and faster. It shouldn't be. In fact, that's not behaving how it should in general, because what we're doing here is we're resetting, when this loops, we're resetting the speed, and each particle should have a slightly, oh, that is the X speed, but not a slightly different Y speed. That's what we need to do, is we need to make the density random as well. You can tell when we get past the scripted part of the tutorial. It's still going faster and faster. Ha 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 ha! Alright, you're gonna want to clip that one, Rusty. Did you see what I did wrong?
Oh, I got you. I can. Don't you worry.
Yeah, I had speed Y instead of speed X. Sorry, I had speed X instead of speed Y. That's why it's still flying. In terms of density, yes, I absolutely want to have a random density. So what we're going to do is we're going to say math dot random so we'll say times 30. So that'll give me a random number between 1 and 30. And then I'm gonna divide that by 100. And so that should give me a random number between 0.01 and 0.03. And then I can take this entire thing and make it negative to make it a negative density. So now each smoke pellet will have its own random density between negative 0.1 and negative 0.3. So some particles aren't going to be moving especially quick, especially if we were to adjust gravity and make gravity even less. But let's push this and make sure that that's working the way we expect it to. See, without the unplanned stuff, we'll never get the bloopers. If all this code was canned, I would never make a mistake, and then no one could ever laugh at me.
Don't you worry.
We'll find a way to laugh at you. See, it's already starting to look a little bit more. Oh, it's like it's a curse spreading. That's really cool. Like, this is why I like playing. For anyone that's still watching, this is why I like playing with code, because even though this is not the result that I'm going for, I knew it wasn't going to be. I'm slowly getting to the result I want. But this is something that I could definitely use somewhere else. I now have like a new visual technique I can use because I created an accidental really cool particle effect. In fact, I'm going to crank the number of particles, and I think this is where we'll end tonight's particle tutorial, because we got like a good half hour into it. And then I'll do another one tomorrow, hopefully around the same time. But before we go, let's crank up the number of particles and see what this looks like. I think it looks cool as shit. Anyone in chat think it looked cool? It's Morbin. Fucking Morbin. We'll ban you again. I don't care who you know.
Look what happened!
What happened, babies?
The pizza's broken!
The pizza's breaking?
It's so knocking! The pizza's dirty!
Yeah. It's kind of like the old school teleport. You know how they did that, right? They put some sparkles in some water and they stirred it, and then they rotoscoped it. Any questions? Let's open up to questions really quickly from anybody, both in Discord or in chat.
Yeah, did they really drown the actors?
Yeah, they completely drowned them in water. Any questions in regards to the code? So we've done virtually nothing to the main application, right? All we did is we passed a gravity property through to the particle. All the other adjustments have just been extensions to the particle. So we took the initial particle class, we extended it, we added gravity, we added density, we added an original speed, we overrode some of the speed and positions, we completely overrode the draw me function, so that we could have different gradient colors, and so on and so forth. But what we could also do over time, right? So one way of fixing this would be to have a separate function called set gradient, right? So maybe that's something that we'll do in the next is we'll add a separate function here called set gradient, and then we'll be able, in the original, we'll set a function called set gradient, and then we'll be able to use more of the original draw me function and more of the original particle in our extended object. And really, that's what you're trying to do. You're trying to abstract as much as possible. 1 second, babies. We're trying to abstract as much as possible, but also make each object as inheritable as possible.